Fluid mechanics. We have completed the 5 chapters, and next one is fluid dynamics and flow measurements. In the fluid dynamics and flow measurements, we have the single line questions and single line answers. This chapter is very simple. Okay. In that, first one is Eulerian approach. What is Eulerian approach and Lagrangian approach? What is Lagrangian approach? In the Eulerian approach, we will consider a group of fluid particle. Okay, we will consider a group of fluid particle. In the Lagrangian approach, we will consider the individual fluid particle. See, here is a group of fluid particle. Here is individual fluid particles. Next one is Bernoulli's equation. In the Bernoulli's equation, we have the equation of Bernoulli's equation, that is P by gamma plus V square by 2G plus Z equal to constant. That is constant. You can represent the C or K as your wish. Okay. By this performing this Bernoulli's equation, you will get from the integrating the Euler's equation. So we have the Euler's equation. By integrating that equation, we will get the Bernoulli's equation. So that total derivation part is not important for us. Final result is required, and the units of each term in the Bernoulli's equation. So by doing the units of total equation, we will finally get the Newton meter whole by newtons. This is the units for the total Bernoulli's equation. Okay, Newton meter per Newton. The Bernoulli's equation and Euler's equations are derived or based on these two equations are based on the law of conservation of energy. And each term represents the energy per weight or energy per force. This is about the Euler's and Bernoulli's equation. In that, next one is continuity equation. What is the continuity equation? We know that the formula A1 V1 equal to A2 V2. So this continuity equation is based on the law of conservation of mass. This is energy. This is based on the law of conservation of mass. So in the Bernoulli's equation, we have the P by gamma plus Z. This total whole term we can call as piezometric head, and V square by 2G. In the V square by 2G, this total term we can call as dynamic head or velocity head or potential head. Therefore, total head equal to piezometric head plus dynamic head. What is the piezometric head? We have the equation P by gamma plus Z plus velocity head equal to V square by 2G. This is total head. The pitot tube. What is the use of pitot tube? To measure the velocity head or velocity. And piezometer. This is pitot tube. This is piezometer. To measure the hydraulic gradient. This is useful to measure the hydraulic gradient. The assumption of Bernoulli's equation. It is very important. What are the assumption of Bernoulli's equation? By considering this assumption, the Bernoulli's equation is derived. Okay, fluid is ideal, steady, it is continuous, it is incompressible, and it is a non-viscous and irrotational. These are the assumption of the Bernoulli's equation. So next one is the application of pitot tube in the pipes. So we have discussed the pitot tube. What is the use of pitot tube, and what is the application of pitot tube? So we will get the direct question from this formula, that is P equal to root of under root 2GH. In that, H equal to X into Sm by S minus 1. What is the Sm here? The relative density of manometric fluid, and small s here, this S equal to relative density of the flowing fluid. In the pitot tube, he will give the what is the flowing fluid in that. So according to the given question, we can use this. So in some questions, he will directly ask the H value. Okay. So hydraulic coefficients. These hydraulic coefficients, we have the relationship and direct formulas. Okay. In that, coefficient of discharge equal to coefficient of velocity into coefficient of contraction. So what is the coefficient of contraction? See, area of the jet at the vena contracta or vena contraction by area of the orifice. See, area of the jet at vena contracta. So we know that the jet, for example, this is the jet. When the water is coming out from the orifice, so at the area of the this water flowing in here, that part is somewhat decreases the area. So that part is contractor, nothing but vena contracta. Okay. So we will discuss in orifice and mouthpieces what is the vena contracta. Okay. Next one is coefficient of velocity. What is the coefficient of velocity? Actual velocity by theoretical velocity. Actual velocity by theoretical velocity. V theoretical will be denoted by VTH. V suffix TH. Okay. Coefficient of discharge. Actual discharge by theoretical discharge. Actual discharge by theoretical discharge. Here see, for the V theoretical velocity, V actual velocity equal to coefficient of velocity into V theoretical. Here V theoretical equal to under root of 2gh. Okay. Next one is devices and their uses. This is very simple and very important for us, in that venturometer and flow nozzle, orifice meter, bent meter and rotameter, these all meters are used for the rate of flow. Rate of flow nothing but discharge. Okay. Pitot tube, it is used for the velocity. Hot wire anemometer. Hot wire anemometer is used for the air and gas velocity. For the calculation of the air and gas velocity, we will use the hot wire anemometer. Current meter. For the current meter, what is the use of it? Velocity in open channel. OC nothing but open channel. In the open channel, how we will calculate the velocity? By using the current meter. Okay. Siphon pipe. What is a siphonic? See, what is the use of siphonic pipe? By using the siphonic pipe, we will collect the water from the lower elevation to higher elevation or higher elevation to lower elevation. The maximum height recommended to avoid the cavitation in the siphonic action. In some cases, the cavitation may occur. So, to avoid this cavitation, the maximum height required the siphonic pipe is 7.8 meters. The maximum possible height is 10.3. Okay, this is 10.3. So, before the applying the siphonic pipe or use the siphonic pipe, all the air is removed. All the air is removed from the pipe. Then water will be flow. Water will be flow through this. Okay. So next one. This chapter is not completed yet. In another next video, we will close this chapter. Okay. Up to here, this is devices. Next one is orifice, mouthpiece. We will discuss in the next class.